Hey guys, welcome back to Introduction to Computer Networks at NTU again. And hi Hassan. Alright, so yeah, let's go over the assignments due this Saturday and check out what's ahead next week. So yeah, gentle reminder, PA3 finally will be due this Saturday. And I see that many of you have already completed PA3 and go on with PA4, and some actually went all the way to PA6. Okay, good for you. And we have 3 quizzes due, 12, 13, and 14 due by Saturday. Guys, these 3 quizzes are a little bit more challenging. Okay, well actually a notch more challenging than the quizzes last week, because The quizzes last week mostly are straightforward. So among the three, quiz 13, which is coming up tomorrow, requires that you get the ideas of the three application layer protocols we've already talked about, HTTP last week, and this week, today, SMTP, that's the supporting protocol for email. And tomorrow, much of tomorrow, we'll talk about DNS. That's the protocol to support the name translation service. Okay, that we'll talk about. So make sure that you understand these three protocols, because you'll be asked to design an application and ask which model that these three protocols we've introduced you will prefer implementing for your application. Now, for quiz 12 and 14, I think the answers are not clear. In any of the videos we'll be showing, I did not tell the solutions explicitly. So for these two, you might need to exercise a little bit of common sense, your previous experience, and maybe a little bit of detective work, all right? So that is the load this week. Now, next week, exam 1 is coming up. That's the major load. And this week, in fact, tomorrow, after the lecture, 10 minutes after the lecture, so we'll end the lecture 12:10. 10 minutes after that, 12:20, you guys are free to call in here, because this is going to be the Google Meet link that you guys will all be joining, okay, next week for the exam. So you can call in, make sure that your connectivity is okay, make sure your camera is working, and make sure that you know which angle your camera should be pointing at so that we can take your headshot shoulder up. Okay. So speaking of exam 1, so let me take you to the exam 1 channel. You see Polly has already posted quite a few of know-hows, okay, or cautions, okay. And so you want to read this through. So first of all, the exam is next Wednesday for this duration. But the actual exam time can be shorter. If you recall in the exam link from the course website, or recall the first week of lectures, the exam time is 100 minutes. Hey, wait a minute. The exam time is, I think, 90 minutes. let me make sure. Okay, let's go to the course page. Exams. So if you click into any of the old exams, you should see. Okay, so exam time is only 90 minutes, but you have 100 points to earn. And so I would also say that the exam duration is 10:20 to 12:10, but that's the overall duration. Okay. At the beginning, we might need to do some checks. So I need to do the ID check. So you guys need to come with the camera working, showing your student ID, so I can see the a photo ID of you. So making sure that you are the person you claim you are. Okay. So first of all, yeah, this is the exam duration. But that contains also the time before and after the exam, before the exam starts and after the exam closes. There might be a few things that I need to check at the beginning, and a few things that I would like you to know. For example, when would the results be ready? Things like that after the exam. So the total duration is 10:20 to 12:10. The actual exam time is only 90 minutes. And the exact starting point of the exam depends on when I'm done with the pre-exam announcements and pre-exam ID check. Okay. And second, the exam will be served as a Google form. This you guys should know. So to get a sense how it's like working an exam through a Google form, you want to try the old exams out. Okay. And for the Google form, you need to log into an email. This doesn't need to be your private Gmail. This can be another Gmail account that you've created for the exam. Similarly, if you go to the exam link of the Google of the course page and scroll down, you will see that the old exams are all available: spring 24, fall 23, and all the way to the early 21st centuries, in fact. Okay. But those are in PDF description form. So what you might want to try are these links. So handling anxiety of the exam page. If you click into the midterm exam, you will see that, oh, this is the exam in Google form. And you see that you need to type your name and your student ID and go on. And in order to see this, you need to log in with an email, in fact. Okay, so this is the Google form for the 3 exams for fall 21. They are all very similar, except that the questions are not the same. Okay, so try these out. Maybe quickly walk them through. If you don't know the solution for the questions, still try. Then you get a sense how long it might take to walk through the forms. Okay. So you will tune in to a Google Meet session in the meantime, as you are given the Google form. So each of you will need a working camera and a stable internet connection. And we are going to do the 10 minutes test run that you see in the announcement tomorrow. Okay. I mean, if you are really confident, it's okay to skip it, but you might want to come a little bit earlier than the exam time. In the previous semesters, I see some students coming or calling in as early as 9:50. So probably will try to be there by 9:30. Okay, but I might be late. Okay, so if the lunch hour is not convenient for you tomorrow, maybe try next week, much earlier than the exam time. So I still recommend that you guys try tomorrow so that you make sure all the technical issues are addressed before the exam, so you can focus on answering the exam questions, so to speak. Okay. So this is a little bit long. This is just to explain why we need the Google Meet session, because it's part of the university regulation for the online exams. Okay, and this is also important because in case you have questions, that Google Meet session facilitate Q&As, and that Q&A will be also observable, audible to the rest of the class. Okay, so that we can address a question just once, not repeatedly. All right. And the exam scope will be announced tomorrow. By the end of tomorrow's lecture, we'll know a little bit better what the scope will be. But what I know for sure is that for the PA questions in the exam, we'll cover PA 1 to PA 3. And number 5, the exam is super long by design. So chances very high the 90 minutes will not be sufficient for you to answer all the questions. So it's not the regular exams where you'll be able to complete and come back to check and double check and maybe triple check. Okay, so this is to let you know that it's natural that you don't answer all the questions. Now, very few of you might be able to answer all the questions. Okay, good for you. But for most of you, it's okay. By the way, how you do with the exams is just the way you check. If you spend a lot of time preparing it and it's still challenging to you, then it says something about how you might do well with ease on the subject. Okay, if you don't spend much time and you do well, then that is your thing. Okay, definitely pursue further. So that if you pursue further, then you might find yourself relatively superior. okay? Easier solving those problems than the others. And that's your game. That's your niche. And see if you can pursue a career that direction. Okay? And just so that you know, some of you might do really bad. But it's okay. Poly does not judge students by the exam scores. Okay? Poly judge students a little bit by your effort. Okay? Those who try really, really hard and yet are not getting good grades, Poly will still like you a lot. Okay? That says a lot about humanity and a lot about you. All right, so 6 and 7, from this point and on, these are just cautions. Something working more like reminder or advices. Okay, it's not necessary. So after filling the basic information such as name and student ID, you might want to submit an empty form first. Because the Google Forms interface can be a little bit confusing. When you submit the first time, they will say, the Google form will actually alert you. You can only submit the form once. But what they meant is that you can only submit the form once with that particular email address. Okay? Which means one person submits one form, and that is what the exam is for. But you can submit a form multiple times to override the previous submission. All right? Okay. So you can submit an empty form first. You will come back to the form and revise your solutions as well. Okay. So after you submit, in fact, you will receive an email. In that email, it contains a link. If you click in, you can come back to the form again and continue on with working on the form. Okay. So you can come back and continue answering later. So please do submit the form multiple times during the exam, because that submission, it might be running over TCP being reliable. But you see, from time to time, we might still run into situations where TCP might not be able to catch all the losses. Okay, so submit multiple times. Make sure that, so it's a little, when you submit, it's almost like committing certain amount of solutions that you already worked on to Google's system, to Google's database. Okay, so if you don't submit and accumulate your solutions all the way, and if you hit submit and that transmission failed, it can be a little bit disastrous. All right. It depends on your web browser setting. Some of you do not cache content for security reasons, for privacy reasons. That could be a little bit disastrous. Okay, so doing the submit, let me just put it this way: it's almost like you commit or save a file into the hard drive. If on the Google form, if you submit, it's like saving a copy of what you have now already to Google's database. All right. So there's still a chance, but the chance is now lower that your submission fail. Okay, but from previous semesters and particularly earlier semesters, earlier years, I've seen a couple cases the submission failed. Okay, you see that you try to submit in the middle of the exam is a good thing, because towards the end of the exam, many of you will try to submit at this. Many of you will submit at the same time, about the same time, because it takes times to complete a submission as well, you see? And so the server could be a little bit busy. As a result, the chances of missing packets will be higher. How do we modify the form after submitting? I didn't get it. Okay. After you submit, you will receive an email from the email address you log in to for the Google form. To work on the Google form, you need to log in to a Gmail account. So after you submit, from that Gmail account, you will receive an email. In that email, it will say, hey, we have received your form. Here's the link that you can edit the form further. Again. Luis, is that clear? Hopefully it's clear. Okay. guys, if it's not clear, just say it out loud on the live chat, all right? All right, so you can edit the form multiple times. Okay, good, very good. And as you see that towards the end, every one of you will be submitting or committing the last time, okay? So it might take a little bit longer. So there's a grace period of some 10 seconds. So if you are a little bit late, it's okay. A grace period of, 5 seconds, okay? Yeah, so you want to do the submission within the end time plus 5 seconds. Okay, you want to submit within the end times plus 5 seconds because we're going to see that timestamp on your submission. But I think the advice is still that perhaps by 10 seconds before pollys say, hey, it's about to end, then submit. Okay, that is the best thing to do. Because I'm actually not quite sure how accurate the timestamp is. Okay, it might be a timestamp at the end of the submission, not the time you hit submit. Okay, and they recall the penalty is severe if you submit late. All right. So within 1 minute, there's 12 points deducted, and for an exam, 12 points is a lot. Okay, so submit maybe a few seconds before the actual deadline, all right? After you click submit, by the way, when you hit submit, there might be a CAPTCHA that you need to complete as well, right? So definitely try to submit earlier so that you get that CAPTCHA done. So later on, maybe they don't prompt you for the CAPTCHA, okay? Yeah, I know, it's a little bit challenging. The questions challenging the practical and programming skill. Okay, so bullet 9 and a few other things related to the questions related to the programming assignments. Let's talk about that tomorrow, because otherwise I'll be running out of time already today. All right, good. So announcement, exam 1. And today we talk about how to fill the Google form. The penalty. Tomorrow we'll continue talking about the part related to the PA. So in the exam there will be PA related. So you need to go online and work on problems that's similar to the programming assignments. Okay, so definitely check out the old exams. You will see a little bit better how the PA related problems will look like during the exam. Okay, good. Now, finally, let's start with topics today. Okay. Last week we started introducing the first application. This week we'll introduce 2 more: email and DNS. In fact, all of these 3 are running in the client-server mode, but the communication model can still be rather different and different in its structure. So today you will see email runs in 2 levels of hierarchy, although still in the client-server mode. Tomorrow, DNS, you will see more than 2 levels of hierarchy. And next week, or maybe the end of tomorrow, we'll introduce yet another application. That's the 4th application, but it's running in the peer-to-peer mode, peer-to-peer model. All right. So that's the overview before the first exam. And last week, we're almost done with HTTP. Okay, that's the protocol to support web browsing. So in addition to HTTP to support web browsing, we introduced also a few mechanisms, for example, cookie, for example, local cache, to try to enhance the performance, to increase the convenience, usability. Now, there's one thing called web caching we started talking about, and we introduced the idea. Potentially, it will reduce the cost. Okay, it will reduce the amount of traffic going through between the client and the origin server. It would also reduce the response time. Okay, and we try to sort of compare the no web cache HTTP versus the web cache HTTP in a quantitative example. So last week we already run the scenario. okay, for the quantitative comparison. And that scenario is in short this. We have a bunch of origin web servers at the top, and there's an institutional network where the clients are. And the link between the institution network and the rest of the internet, that link has narrow bandwidth, so it becomes a bottleneck, and therefore we need to wait a long time. There's a long queuing delay. So that was scenario 1 is about. Scenario 2 is the simple fix, expanding the capacity of the bottleneck link so that it's no longer the bottleneck, and therefore we don't have the queuing delay anymore. So we speed up the response time, okay? But this solution is costly. So scenario 2, very brief, about 2 minutes. In scenario 2, let's try to address the issue here, because this is the bottleneck link where the delay came from OC. And let's blow it up 100 times. How about that? So using a fatter access link there. The result is that the access link utilization is also reduced 100 times. Less than 1% utilization, you can imagine the queuing delay being very, very short. That brings this component of the delay down to milliseconds. Now, why millisecond? If you recall trace route testings that we did earlier in chapter 1, right? What was that? Quiz 3 or quiz 4, isn't it? Yeah, most of the delay we see between 2 routers are what? Tens milliseconds and maybe 100 milliseconds at most. So if there's not going to be much queuing delay, yeah, the delay is at this scale. So 2 seconds, milliseconds, microseconds, which of these 3 components dominates? Obviously, 2. And from scenario 1, we have minutes of delay, to scenario 2, we effectively bring down the total delay. All right, great. Is there any catch? If you think about it, hey, bringing the access link capacity up 100%, that is actually not cheap. So increasing access link speed, no, not cheap. You need to purchase the new cables, of course, but you might also need to do groundwork. Okay, remove the old cables, install new ones. Just think about the labor cost there. And in addition to that, you might need to upgrade the routers there connecting the high-speed link, just so that you can accommodate potential traffic volume. So, yeah, very costly. Now, in scenario 3, let's see if we could introduce something else instead of blowing up the capacity in the bottleneck link. Yeah, so it's a straightforward solution. Just expand the capacity, then we don't have that much queuing delay. But it's very costly in practice. You need to dig the ground up and then install additional hardware, additional cables, or new cables. That's very costly. Now, web cache is the second solution. So this video is a little bit long. In the first part, you will hear that the solution, at least using web cache, is much cheaper. Okay, but in the middle, you will hear there's a keyword called hit rate. You see, cache, it means it's data stored temporarily for future use. Now, whether this cache is effective depends on whether the future uses a lot of the data we have cached. So if it does, that's hit. Otherwise, it's miss. When the hit rate is higher, then yeah, it's more efficient. Okay, so you will see Poly introducing this hit rate because eventually we'll calculate the response time with the web cache. And how the response time can be reduced depends on the hit rate. Okay, so 3 parts in this video. And this video is by far the longest, 7.5 minutes. Pay attention. In scenario 3, instead of blowing up the access link, let's install web cache here. I'm calling it the local web cache because we are very close to the clients. All right. Oh, and yeah, I meant local web cache here. Okay. So that you are not confused with the local cache we've talked about in conditional get, where that cache is actually very, very local on the hard disk of the user. All right. So we are only slightly local here. So let's see. Good. So everything else stay the same. All we did is just install the machine. Now, if I ask you, changing this to 154 megabits per second versus adding a server machine, which one is more expensive? Yeah, you probably guessed, right? Labor costs, routers are expensive, cables sometimes can be expensive depending on the distance between the physical distance between the two routers. For your information, this could take millions of new Taiwan dollars. But installing a high-end server machines, it only takes this much new Taiwan dollars. So that's about 2 order of magnitude difference. Yeah. Installing web cache, so much cheaper. Great. Now, let's see if the delay is also going to be better. Or maybe if this is cheaper, then delay is going to be worse. Now, let's try to calculate this. We know the LAN utilization, and so maybe the LAN delay is also about, microseconds. But access delay, well, we'll have to know the access link utilization in order to estimate the access delay. Therefore, question mark, therefore we couldn't quite yet estimate total delay, right? But then, so this has something to do with the traffic that needs to be brought down this way, right? How many objects will be coming down this way? That seems to be the question. And if you think about it a little bit more, isn't that depend on, for all these web requests we send to the proxy server, how many of them are going to be satisfied locally? Therefore, we could just, transmit the object from the web cache through the LAN to the clients without going all the way up to the servers. So that is this thing called the hit rate. Okay, amount of the proportion of the requests being satisfied locally, that's the hit rate or the success rate. Yeah, let's suppose the hit rate is 0.4. Then we see 40% of the requests will just stay here. Only 60% goes out and back. Great. So we know then the access link here, the utilization is 60% of the access link, 60% of the scenario one. And how much is that? 60% of the traffic, then it's only this much traffic on the 1.45 megabits access link, only 58%. So we cut the utilization from 99% to 58% if we ended up having this hit rate. Now let's calculate the total delay. So 60% of the time it's going to be long delay all the way to the server and back. 40% of the time just on the local LAN. Now, local LAN delay, we've seen earlier, microseconds, but I'm using the milliseconds here just to take into account the traffic here. So if we go out, request object down to the web cache, and then web cache serve the local client, we have one copy down here and another copy down this way. So the LAN here, the traffic potentially could also be higher. So let's use milliseconds just to be safe and take that extra traffic into account. Now, for the 60%, we'll have to go out and back, right? So this is very negligible. This part is what? The key component. This part, 2 seconds, we know for sure. So what's remaining is just the delay here on the access link with 58% utilization. Well, how much delay is this? If there's a lot of queuing delay, we go minutes. If very, very low, only 1%, we go milliseconds. So minutes, milliseconds, well, that's, saying tens milliseconds or hundreds milliseconds, right? So I'm trying to be a bit generous here and use 10 milliseconds only. And so total delay here about 2.01. And 60% of that plus 40% of milliseconds. The dominating component is the 2 seconds. So you see here, the overall total delay on average is going to be about 1.2 something seconds. Is this better than scenario 2? It is, right? Scenario 2, you had at least 2 seconds. So what's amazing about web caching is this. The benefit is not just that it's cheaper, but the delay is also lower. And the traffic coming down this way is also lower. Hey, we did not spend any money here, and we also saved some bandwidth here as compared to scenario 1. So there's more traffic can come down this way. Isn't it nice? And that explains why we need web caching. All right, it's to reduce the delay. This is also called the response time. Okay, that meant the time it takes to issue the request all the way to the server and bringing down the web object, the round-trip delay of the request and response messages. It also reduces traffic, save a lot of bandwidth on the access link, and it's very cheap. Now, an extra benefit we didn't talk about is because we did not assume the uplink bandwidth of the servers being the bottleneck. If the server is poor, meaning having a poor content providers out there, then, let's say that the server here is poor. It cannot afford too high bandwidth uplink. Then reducing the amount of traffic going this way also saves poor content providers some resource, some money. And so web caching there also help the poor content providers to deliver content. All right. And this could be a good thing because most of the NGOs, they might also have information to disseminate, but they couldn't provide good uplink bandwidth. And that actually gives rise also P2P file sharing. The idea of P2P file sharing is also, hey, if I have the copy of the content and another peer grab a copy of it, then this other peer can help serving the other peers. So that peer there is working pretty much like a web cache, isn't it? Like a proxy server. So you could actually think of a P2P network, a network of these proxy servers. Okay. And you saw a bit already. Next slide. Coming next is going to be the second application in chapter 2. And we'll look at how FTP defines its application layer protocol. All right, so now we're not going to talk about FTP. We'll skip FTP this semester and go down to the email, okay, the second application straight. There's a question from Henderson asking, hey, what about, so that proxy server, that web cache, that local web cache, is it managed by the institutional network? It is. Okay. Usually what the institution network admin does is to purchase a machine, definitely some storage space, and then install such a web server. And the tricky part is to configure the caching policy. So for any cache, the tricky part is the caching policy because it determines how efficient the cache is, how much lower the response time we can reduce, and how much traffic we can reduce. All right, so Henderson, short question, yes. Longer question is, yeah, so it can be a little bit tricky for the admin to configure such a web cache. And now we move on to the second application, email. Okay. The first video is going to introduce the communication model. Let me just break the news. Email, the supporting protocol is called SMTP. It's also client-server based. Okay, but it's different from HTTP in a way that there's two levels of hierarchy. 2.3, emails. So this application is a little bit unusual. It's supported by not only one application layer protocol, but multiple ones. And we'll talk about it more. Email application. It's got three major components. First is the user agent. This is the software running on the machine closer to the users. And mail servers are the software running on more resourceful machines farther away from the users. And among these mail servers, it runs this protocol, SMTP, the Simple Mail Transfer Protocol. These we'll also talk a bit more about that start from the user agent. They're essentially the email readers. They allow us to write email, edit email, read emails. Outlook from Microsoft is one mail reader that's very well known. Thunderbird, I don't know if you know about this one. This is from Mozilla. So the company that produces also Firefox, the very well-known web browser. iPhone comes with a built-in mail reader. Google is also trying to push for a Gmail mail reader. So there are so many of these email readers these days. Now, keep in mind though, the actual emails are all stored on the servers, not on the user agent these days. All right. Now the mail servers. It's got these three major components. The mailbox, which contains all the incoming messages per user. So these are the yellow boxes. when emails come in, they will be sorted out and then put into the email boxes depending on who the receivers are. Second component, the message queue. Those are the green queue over here. So messages that are going out will all be stored here temporarily and waiting for the receiving mail server to open up and then accepting the emails. So SMTP protocol there is to allow the sending server and the receiving server to communicate. Now here in particular, the sending server there is called the client of the SMTP protocol, and the receiving server is, on the other hand, the server of the SMTP protocol. So you see a little bit here, the SMTP protocol is to provide mail receiving service in a sense. So client here requesting service, server here allowing emails to come in. If you think about it more, it's got two levels of communications in the email application. So this is one between the end users and the local mail server. Okay, fetching email or pushing email out. But there's another level, which is among the mail servers. All right, so sending mail server is the client of the higher level communication. Receiving mail server is the server of the higher level communication. Then the SMTP protocol. So this is the actual application layer protocol defined to support communication in emails. So let's see, what are the underlying protocols and what is the communication model and what are the messages defined? TCP you see here. Therefore, SMTP is to support reliable email receiving service. It runs on port 25 and the transfer is direct between the sending and the receiving server. The exchange, very simplistic, 3 phases, handshaking, and then extra transferring of the emails, and then closing. Opening, closing, the extra transferring of the emails in between. The messages are also simplistic. They're just comments coming from the sending server, responses coming from the receiving servers. So comments in ASCII code, just like HTTP, just like FTP. Responses, status words, status phrases, status code, just like HTTP and FTP. They all run in the ASCII code. Now put all 3 major components together and let me illustrate with a concrete scenario. Alice here is sending an email to Bob over there. All right, so Alice will need to start the user agent first to compose an email. So in the email, it will need to specify the receiver. And then the user agent will send the email to the message queue, okay, in the local mail server. So that is step 2, emails going to the message queue. And then the client side of the SMTP, which is here, this guy is the one sending, and this Bob's mail server will be the one receiving. So this is the client of SMTP. This is the server of the SMTP. So client side of SMTP will open up a TC connection. Once the server is allowing the connection, then the client can begin sending Alice's email. So that email will travel, and the server here of Bob's will check whether the receiver is Bob, and therefore putting the email into Bob's mailbox. Right? So email goes to Bob's mailbox. Lastly, when Bob now joins the internet, invoke his user agent, then the agent already pre-configured to connect to the incoming mail server will then fetch the mail messages, and that's when Bob gets to read the email.
All right, so that's the overview of SMTP. You see also in the middle of the video that the comments being exchanged between the SMTP server and client are also readable ASCII text. Okay, that is very similar to HTTP. Okay, and towards the end, you see a full example of an email coming from Alice, eventually reaching Bob. But you see also that SMTP only runs between Alice to the sending email server and the sending email server to the receiving email server. From Bob to fetch the email, that is not SMTP. All right. You know what? This week or today, we're going to run this way because quiz 12, we can do it after we finish talking about mail access protocol or now. So judging from the time we have, it's probably better to do it now. So we'll go ahead and jump to quiz 12. Okay, this question requires that you exercise the common sense and a little bit of detective work. So let me go to the whiteboard mode. Okay, so this is quiz 12. All right, good. As you see in the example, right, from Alice sending an email between Alice and the sender's mail server, SMTP. Between the sending mail server and the receiving mail server, SMTP. But between Bob and Bob's mail server, it actually is using another protocol called Mail Access Protocol, which we will talk about early tomorrow. Okay. In fact, we'll actually introduce POP3, a very popular but a little bit old, okay, Mail Access Protocol. Now the question here I'm asking is, why not SMTP all the way to Bob's user agent? Okay, let me offer a hint. If you recall, right, SMTP, when we send, for example, the email from the sending agent, from the sending agent to the receiving agent. Which one is the server? The receiving one is the server. So the direction is actually different, right? Recall in HTTP, the one receiving the content is what? The client. Okay, so this one is the server. Now we want to send the email further to Bob, but is Bob a server? Can Bob be a server? Okay, so that's all the hint I have to offer. Let's go to the score. Hassan is already here. Let's go to channel W5, quiz 12. Okay, why? Why not SMTP all the way to Bob? All right, so you guys have 3 minutes. Okay, that's start counting time. Yeah, guys. Because SMTP expect to send emails to a machine that is always on, so that connection can be established, an email can be pushed there, and that server will then store all the incoming emails there. And so when Bob is online, Bob can access this receiving mail server for his emails. Yeah, I think most of you get it, because Bob's computer, for example, your laptop, is not a mail server, obviously, but you are reading emails. But what you do is, when you are online, your browser or your email reader will go connect to your receiving mail server and fetch your emails. Okay? And that is just not the way SMTP works. SMTP pushes emails, okay, from the sending server to the receiving server. Now you hear another keyword, push. And HTTP is what? Pull. The client asks the web server, and web server sends the content back. So the client is pulling the content, the data from the server. Okay. All right. So I actually give bonus to team 13 and I think another team 2 as well, because they say a little bit more here. Bob's local in. Bob is not going to be 24/7, right? Having online, okay, waiting for emails to come. Because server usually have a IP address that's clear to the client. Otherwise, the client will have trouble reaching the server, right? You guys, your laptop, you might be 24 hours online, but you are probably walking from here to there. You were at home earlier today and then coming on campus for the classes. But the IP addresses you use are changing. That's another way of saying that there's no way you'll be a server. Because your mail receiver server there will not know where you are and push the mail further. Okay, so the user Bob is obviously not sitting there all the time and waiting for the mail to come. So that's the difference between a client and a server. So the machines that are moving around, changing IP addresses all the time, can be on and off, are not servers. Okay, team 2 is also saying something. Yeah, Bob may not be online all the time. All right, good. So, so we know SMTP works in a way that the sending side is the client, receiving side is the server. So you expect the server to be on all the time. And therefore, Bob obviously cannot be the receiver end of SMTP. But Team 2 and Team 13 offer a more detailed explanation why. Okay? And you know what? That is all the time we have. Tomorrow, we'll continue to talk about email and SMTP. Okay, but there are just three videos left. All right, good. And let me check. Yeah, permanent, public, very good. All right. Okay. So you see that very often, how Poly give bonuses to the quizzes are the one that respond faster, or the ones that elaborated, okay, their answers. So you see a little bit more clear why. Okay, good. And guys, that's all the time we have today. Tomorrow, yeah, I know there's not many. We did not play many videos. That's expected because Poly needs to explain how the exam works. Because doing an exam on a Google form is a major change for all of you. And Poly wants to be careful and make sure it's clear. Good. Tomorrow, at the beginning, we'll also spend some time so that you guys get a better idea how you do the PA part of the problems. And there's a change this semester versus the previous semesters. Previous semesters, I would actually disable the firewall, so you guys don't need to VPN to NTU to work on the exams. But this semester, we'll need to keep the firewall on, guys. So it can be a little bit more challenging and a little bit more consuming to work on the PA part of the problems. But guys, still, given the same amount of time. So you're given the same amount of resource and you're given the same set of problems. The point of the exam is so that you guys can compare relatively how you do between each other. Okay, it's not so that you guys all get 100 points. Okay, at the end, then everyone is happy. Okay, so to some degree, after taking courses for years from the primary school, maybe, yeah, you know that the scores you gain says a lot about you. Okay, but guys, the scores you receive are not the only things that's said about you. Okay, good. Just so that you know, one more time, Polly admires those who work really, really hard despite the outcome. Okay, and that is when usually great things happen, breakthroughs happen. Okay, but good for you if you find that there's not much effort required and yet you perform really well. Definitely pursue a career there. It's gonna be easier. Okay. But sometimes what you're really good at might not be where your interest is. So if you stick to your interest, okay, and work 10 times harder, okay, than the others, hey, let me just say that I admire that very, very much. Okay. All right. So hey, guys, go. And here's the cue to say goodbye. I see you tomorrow. Okay, bye. Very good. Okay, bye. Okay, bye. That's all. Bye.